Hi everyone, so today I have another really fun problem for you, and today we are going to be discussing about calculus, more specifically limits, and we're actually going to see how this concept of limit works, right? How can we approach problems involving limits? This is a problem. This is the problem number 7 from the ISI Entrance exam in 2022, and in this video we're going to be learning about solving problems involving limits. We're going to look at the standard way to solve limits of the form 1 is for infinity, which is one of the 7 indeterminate forms in mathematics. Then we obviously have some book suggestions for the ISI CMI, and then at the end we have a similar but challenging problem.
This video is sponsored by Cheenta.com. Since 2010, Cheenta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
Let's begin. So we have p of x defined as 1 plus 2x plus 7x squared plus 7x cubed, and we have to calculate this limit for all x belongs to real numbers. So whenever you have a limit, and limits is one of the common calculus problems in ISI CMI, and whenever you really see a limit, one thing that you can maybe do is actually see what value that limit tends to, or what indeterminate form the given limit is forming, right? Okay, so we have p of x is 1 plus 2x plus 7x squared plus 13x cubed. That's excellent, because p of x by n would then be nothing but 1 plus twice of x by n plus 7 times x by n whole square plus 13 times x by n whole cube, right? And if I just raise this to the nth power, that would be 1 plus 2 times of x by n plus 7 times of x by n whole square, and this term with the 13 raised to the power n. Now if I take this limit as n tends to infinity on both sides, I will actually get 1 raised to the power infinity on the right hand side. Now why is that true? Because if you notice, n is on the denominators in these three terms, right? And when that is the case, when n is basically the denominator, what essentially happens is that as it tends to infinity, the denominator is really large, right? And whenever you have a really large quantity in the denominator, the entire fraction tends to 0. For example, 1 raised to the power 1 million, or not 1 raised to the power of a really high quantity compared to 1. This roughly tends to 0, right? It's going to be very, very, very small quantity. So essentially, all of these terms would tend to 0, and this would eventually converge to 1 raised to the power infinity of that form, essentially of the limit. Okay, so now that we have reduced the ranges of the form 1 raised to the power infinity, let us look at a standard way, or one of the more common ways to solve such indeterminate quantities. This is one of the 7 indeterminate quantities in mathematics, in limits. And to solve this, we essentially use a fact, or essentially use a property of logarithms, which essentially says that for any number k can essentially be represented as a raised to the power log k to the base a, right? So any number m can be written as e raised to the power ln m, right? As ln is natural log with base e, so this is essentially the same thing. And if we use that, we can actually solve this problem fairly easily now. Now, firstly, observe that p of x by n can be written as 1 plus p of x by n minus 1. Right, this seems actually quite trivial, but let's actually see how this helps us. Now, p of x by n raised to the power n would be equal to 1 plus p of x by n minus 1 raised to the power n. And now I want to write this in the logarithmic form, in the exponential form, as I had shown you earlier. So this quantity on the left hand side can essentially be written as e raised to the power ln 1 plus p of x by n minus 1 raised to the power n, which is nothing but e raised to the power n ln 1 plus p of x by n minus 1. Okay, now, well, what do we do next? So next, there's something called as a Maclaurin series, or rather the expansion of ln 1 plus x. This gives us x minus x squared by 2 plus x cubed by 3, and so on and so forth. This expansion of ln 1 plus x is called as a Maclaurin series. Maclaurin series is nothing but the Taylor series centered about a is equal to 0. That's a single point of the series. So if you know this expansion, this can actually become pretty trivial from now. So I'm just going to write ln 1 plus x as this. And in our case, in the problem, we essentially had e raised to the power n times ln of 1 plus a certain quantity, p of x by n minus 1. So 1 plus this quantity over here, right? So now writing it in the form that is given to us using the expansion, we will get e raised to power n, and this would become nothing but 2x by n plus 7x squared by n, n square actually, plus 13x cubed by n cubed, and certain other terms, right? And this, now if you take limit as n tends to infinity of this, which is asked in the question, of this given quantity, 2x by n plus 7x squared by n squared, and so on and so forth, you would essentially get the limit as n tends to infinity of e raised to power 2x plus 7x squared by n plus 13x cubed by n squared dot dot dot. So now, like I explained before, this quantity, if we have a quantity tending to infinity on the denominator, all of these things would be equal to 0. That essentially just leaves us with e raised to power 2x, which would be the correct answer. So therefore the limit as n tends to infinity of p of x by n raised to power n is equal to e raised to power 2x, which is the correct solution. So I hope you really like that, and I hope that you kind of got the idea of how to solve limits, especially the indeterminate quantity 1 raised to power infinity. Okay, so after that we have certain book sessions for calculus and ISI CMI. We have pre-calculus by Tarasov, single variable calculus by Maron, playing with graphs, which comes in which is printed by the Arihant publication, challenges and thrills of pre-college mathematics, mathematical circles, excursion mathematics, and a test of mathematics with 10+2 level. And at the end we have a similar but challenging problem, and it's basically asking us to find all possible real values of t such that it starts with this given limit, and it's given that a is a real valued function such that this limit actually holds true. So yeah, as usual, just try this problem and let me know if you made any progress on it or if you're able to solve it, and I'll respond to you. Until then, I'll see you in the next video. Bye bye.
Cheenta programs are designed for students who are passionate about mathematics, and they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Cheenta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Cheenta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit cheenta.com.